In lesson 8, we're talking about square roots and irrational numbers. If you were not here for the introduction on page 62 and 63, you need to look at a few important things on page 63. So first, a perfect square is the product of a whole number in itself. So integer would be a whole number, no decimals. The inverse of a square, that means the opposite. So the opposite of squaring a number is the square root. So square root is a number times itself to equal that. So since 3 times 3 is 9, the square root of 9 is 3. But also, sometimes it'll ask you for all of the square roots, and in that case, you want to put the negative down too, because negative 3 times negative 3 is also 9. So it's a number times itself to get whatever number you're trying to find the square root of. The square root symbol is right here. It's like looks like a little check mark and a division symbol. So that is the symbol for square root. You might want to put a star here and a star here and possibly underline the definition of square root so that you will have it. Then also, there are two things that it does say this in this paragraph, but it might be easier to rewrite this. So two things that you should rewrite are rational numbers. There are 3 characteristics of rational numbers. This is on page 63 still. Rational numbers terminate. So all just plain numbers are rational numbers because terminate means they end. They could be decimals the end, or they could be whole numbers. Repeating decimals. So if it's a number that repeats in a pattern like 0.3, the 3 keeps repeating. If you could put the line over it to show it's got a repeating pattern, then it is rational. And all fractions are rational numbers. Irrational numbers are crazy numbers. So irrational numbers are non-repeating decimals. That means the decimal goes on forever. It's an ugly decimal and it has no pattern that repeats. All square roots of non-perfect squares, so that would be, I'll show you what perfect squares are in just a moment. So if it's a square root of a non-perfect square, then it is irrational. And some numbers like pi, which is a number that we're going to be using for circles later, pi is also irrational. So now on page 64, we're ready to start our lesson. Lesson 8 does 2 things. It talks about how to find square roots, but it also talks about how to estimate square roots of non-perfect squares. So on 64, first the question asks us to find the positive square root, so we don't need negative numbers right now, of each number. Are the square roots rational numbers or irrational numbers? So we have 4 numbers here. You should have gotten a multiplication table. So on your multiplication table, the perfect squares are the ones that are in a diagonal, that are the whole number, like 2 times 2 is 4, 3 times 3 is 9, 7 times 7 is 49. Those are the perfect squares. And we were asked to find the positive square root of 81. So we're looking for, why are you not drawing? All right, it was just slow. We're looking for the square root of 81. We're trying to find the square root of 121, the square root of 36, and the square root of 48. So to find the perfect square, we look for it on the list, or on that diagonal. So 81 is right here. So 81 is the perfect square. That means its square root is 9. So the square root of 81 is 9 because 9 times 9 is 81. And then 121. So I look till I find 121. That would be 11 times 11. So the square root of 121, I didn't give myself enough room. That's going to be 11. You're going to write this on page 64. Then 36. So the square root of 36, I see 36 on the diagonal. So the square root of 36 is 6 because 6 times 6 is 36. And then 48. 48 does not a perfect square. 49 is the closest one. So 48 is not a perfect square, so we cannot find its square root because it would be irrational. Now back to page 64. they made a multiplication table here, or they just multiplied and did the perfect squares. You have a multiplication table that you can use to help you with those questions. So now on page 65, we can start answering our questions. So it says, look at the table and model it. Which numbers in the problem were perfect squares? Well, we just figured that out. 81 was a perfect square. 121 was a perfect square. And 36 was a perfect square. So write the positive square roots for the perfect squares. The square root of 81 was 9. The square root of 121 was, I forgot, give me 1 second. So the square root of 121 was 11. And the square root of 36 was 6. Now question 4 is a little bit confusing because it says write all the square roots of 121. So the difference between 3 and 4 is the word positive. 3 wanted just the positive square roots. So the other square root is also negative 11. So the square root of 121 are negative 11 and 11. In the future, you might even see that written down as plus or minus 11. That means it could be a positive 11 or a negative 11. So question 5 then says, write the positive square root of the non-perfect squares. The non-perfect square was 48, so that would be the square root of 48. So question 6, which square roots are rational numbers? So the square root of rational numbers were the ones that had a perfect square. So rational square roots were the square root of 81, the square root of 121, and the square root of 36. Those were rational. Then the irrational square root was just the square root of 48 because it was not a perfect square. And I should have answered, how do I know? I know the rational ones because they were perfect squares, because they were on that yellow diagonal. And I know the irrational one was because it is not perfect square. Now try questions 7 and 8 and check them with the video. So you should have gotten 14, the square root of 160 because 160 is not a perfect square, the square root of 10 because 10 is not a perfect square, and then 4. And then question 8, which square roots are irrational? That was the square root of 200 and the square root of 360 because they were not on our yellow diagonal. And then 200, the square root of 256 is rational because 216 times 16 is 256. So I had some technical difficulties. Hopefully that was not a bad transition. I had to give up on Screencastify, it crashed, and go with Loom. So now we're on page 67. And now we're talking about estimating and plotting irrational numbers. So remember, square roots of non-perfect squares are irrational numbers. Our question says, what is the approximate value of the square root of 5 to the nearest whole number? So if we go back to our multiplication table, we can look and we can see that square root of 5 is not one of our numbers on the perfect square list. However, 4 and 9 are. So we know the square root of 5 has to be somewhere between the square root of 4 and the square root of 9. Notice that that's what they got on the model it also. So now if we look down here for the picture it really helps because they then said, okay, what we just said, the square root of 4 is 2. The square root of 9 is 3. So the square root of 5, it has to be somewhere in between 2 and 3. And since 5 is closer to 4, it's going to be closer to 2 than 3. Now we're going to go answer the questions on page, this is page 67. So what is the approximate value of 5 to the nearest whole number? Is the square root of 5 greater than or less than this whole number value? So we just found out it has to be in between 2 and 3. So we could say 2, and it is a little bit bigger than 2 because 5 is closer to 4 than to 9. Remember, we got the 4 and the 9 from the perfect squares. So now our question says use your answer to problem 9 to plot it. It's going to be about right here. It'll be a little bit bigger than 2. So question 11 says the value of pi is approximately 3.14. Is pi greater than or less than the square root of 5? And explain. Well, pi is about 3.14, so it's about there. So we can say, where's my text box? Sorry. So we can say the square root of 5 is less than pi. Sorry, I don't have the symbols. You can write the symbols if you want to. The square root of 5 is less than pi because it is closer to 2 and pi is larger than 3 because it's approximately 3.14. Remember, you do not have to have the same exact words that I have in my explanation. So question 12 says you can plot the square root of every non-perfect square on a number line. Explain why. Well, why can you? Because you can find the perfect squares that are larger and smaller than the non-perfect square, and then estimate, will it be closer to the smaller or larger perfect square on the number line. So basically you just use your multiplication table to find your two perfect squares and then just figure out which one is it closer to and kind of estimate where you're going to put the point. Now try question 13. Make sure that you do label the numbers above where you put their dots. Okay, check your answers for question number 13, and you were supposed to write the numbers in order from least to greatest, so make sure you also list that it went from the square root of 3, or square root of 2 is smallest, and then 1.7 repeating, and then 5 over 2, and then the square root of 8. Now 5 over 2, I know is the decimal 2.5 because I divided 5 divided by 2. It's not because there's a 5 and a 2 in it. It's because 5 divided by 2 was 2.5.